All right.
Hi.
Hello, everybody. Good morning, good evening, good afternoon, and welcome to the final episode of 2025, final episode of Neo4j Live this year. And it's a good one, I think. I'm very much looking forward to it. Inside StrangerGraphs, predicting season 5 with graph intelligence, and I'm super happy to have you here joining me today, Henry. How are you doing?
Yeah, good. How are you?
Good. Yeah, I'm excited for this. I think this is going to be fun. This is going to be good. I admittedly I haven't watched Stranger Things, so it will be all very new to me. But maybe others haven't watched it either. But I think still think it's going to be interesting, even if you haven't watched it. It's an interesting concept, interesting things we've done with the Stranger Graphs and with the Hopper graph. And what you built with Neo4j in the back end. So I think that's going to be fun and interesting. And yeah, I'm very much looking forward to it. Before we dive in, Henry, do you like to give a few words about what you do at Neo4j? What's your current job look like, and your what you do outside of watching, I guess, a lot of Stranger Things and building building cool apps.
So actually, Alex, I don't know if you know this because we don't talk a lot, but my job is solely watching Stranger Things.
Yeah, that's what I thought.
I don't actually have it. That's what I was hired to do. Yeah, and then occasionally they ask me to put together these little courses and stuff. But mainly it's the Stranger Things stuff. That's what I'm really passionate about.
It's basically binge watching a show and then building a graph analytics app. So
yeah, pretty much showing the real use cases. Financial, fraud, all that stuff. No. That's just for the real fans. But for the true data scientists, it's binge watching Stranger Things. In all seriousness, I basically do whatever I'm asked to do. My actual job role, I suppose, is technical curriculum developer. For developer relations. So I work with the awesome team of other curriculum developers and the head of Graph Academy, Adam, to figure out what people are struggling with, mainly, and then try and give them some sort of learning environment where they can overcome those blockers to using Neo4j. Because, Neo4j is one of those things that, A, is very addictive once you get into it, but B, it's kind of difficult to get into it when you're starting because it seems, this is something I've noticed, right? It seems really complicated when you first look at it. But actually, once you have that moment, that shower click moment, you suddenly realize that no, it's not. It's actually not more complicated. It's less complicated than what you're used to. But that's why it feels more complicated because you're used to relational data. You're used to using abstractions of data. And so then you look at Neo4j and you go, okay, so graph is better than that for most cases. So therefore, it has to be a step above that in terms of my cognitive processes. But actually, in reality, it's a step backwards because with Neo4j or graph in general, you're not abstracting anything. You're actually literalizing the data. I know you, and that is the relation, and that is literally what we're going to put into the database. So we talk about digital twins all the time, and we made a digital twin for this and that and the other. But in a certain way, every single graph is a digital twin.
True.
Anyway, I'm going off on I'll do that. So please feel free to pull me back. I'll go off on mad rants and I'll put the world to rights.
Yeah, no, but it's a good point. I get the feeling. It's for me. I think it looks too complicated and too easy at the same time. Sometimes if you look just a data model and sometimes they can be very easy looking and think, oh, well, this is it, really? This is what it is. And then you read, okay, actually there's a ton of thinking behind it that it looks this easy and this toned down, but actually this is why it works so well, and this is why it then performs this well. But at the same time, you look at it and think, okay, wow, this is, like you said, you come from this relational background and think, okay, everything is a table, and then you all of a sudden nothing is a table anymore. It's like, okay, how does this work?
There is no table.
Yeah, so that's fun. Cool. I put a link in chat to Graph Academy, so very much encourage everybody to look at that and to look at the courses, and they're constantly adding new courses, and it's really an amazing platform to start learning, to start getting the grips of how graph databases work. And yeah, if you have no experience, I think this is great. If you have no experience, also this I think is probably a good show today to give you a little bit of what you can do with a fun theme without being too much into you know, fraud or legal or all these very sophisticated enterprisey topics, but this is more of a fun and games kind of topic. But still, it's adaptable, and everything you see today is obviously adaptable to a business use case. So imagine the StrangerGraphs episodes are individual episodes. Are individual, maybe documents for legal cases or strategy papers or whatever else, and then you kind of like get the idea.
Yeah, I mean there is that, but there's also this process. I actually think doing this process has been more educational in a generalizable sense than using a legit real life use case that you must.
Okay.
I mean, it is a legit real life use case. It exists.
Yeah.
I used it.
Yeah.
But a serious graph use case.
Yeah.
You're right. This is absolutely not serious. It's fun and games, but of course, playing is how we learn.
Yep.
And the beauty of this is, and I've had to make this point a few times, but I think it bears repeating, that this is using graph data science tools. But if we get a chance to go through it and show some of the back end of it, you'll see that it is using graph data science tools, but it's more like alchemy.
Okay.
Graph alchemy. Because yes, we are getting prediction communities and we are getting predictions and so on, but even the definition of who those communities are is very much up to the person inspecting the graph. And the reason why I think that's useful to a learner is because oftentimes you are arbitrarily deciding things in the beginning.
Yeah.
So with a lot of other algorithms that you might be used to, there's a way to run it, and you run it, and you get the results, and you go, cool, those are my results. I'll now share those. But with graph, there's a certain level of art. How much modularity do I need in the communities that I'm defining? How big do I need these communities to be? In what sense am I defining these communities? Because you can use Leiden to define communities, and if you use it in the default, then it's going to define those communities, and you'll go, cool, there are my communities. But maybe the attributes of your communities, maybe your communities themselves naturally are actually smaller, tighter, more modular clusters, or maybe you want to inspect a larger community.
Oh, yeah.
So, in a fraud use case, for example, you might use Leiden or Leiden or something like that to define communities so that you can then inspect. You reduce the dimensions of space that you're trying to search for fraudulent users.
Yeah.
And you might find that same as users will resolve better in a larger graph, because maybe and as an example, I've never done it this way, but I can imagine an example where you make these really small communities because you think that's where, same as fraudulent users will live.
Yeah.
But maybe those same fraudulent users are actually all over the world. Maybe it's James Bond, and maybe James Bond is in Tenerife. I don't know why James Bond is in Tenerife, but he's on a government wage, to be fair, so he probably is in Tenerife. But James Bond is in, Buenos Aires, and then he's in Dublin the next day. And so actually his IP address, the credit cards that he's, all these different things that we're using to resolve may not be relevant for James Bond.
Yeah.
And so they may not be relevant for the use case of finding James Bond in the graph. It might be a good exercise to, anyway.
No.
Yeah. going in
but I get where we're going with this. So I think, lots goes into this depending on, structure and the data model and the actual use case and what you want out of it. So that bears keep in mind, definitely, that we, anytime you build a graph, the structure could be looking a little bit different. Anytime you do that, you have a bit of a different approach to it, and it's just and it's because of the versatility, you can adjust it depending on what you want out of it, and then the structure stays the same. So I think it's definitely a good point. But I think we should come back to Stranger Things, and the idea was, I think, here behind
absolutely not. What are you doing? I'm trying to divert this conversation, and you just keep bringing it back to Stranger Things. Though.
Yeah, well, that's what we're here for today. So we before season 5 launched, a couple of people at Neo4j thought, okay, this could be fun. Let's see what we can do. We always look at interesting data sets, and this could be a fun data set. There's a huge fan base around it, lots of conversations, lots of discussions going on, particularly in Reddit. And let's see if we can analyze those and see if we can actually make some predictions of what's going to happen, because that's the interesting bit. So now we are, I think, halfway through, if I understood this correctly, the 5th season. So I think first drop has been published, and I guess the second drop is launching right after next week or something, right around New Year's, I think.
Yeah, I think the second last drop is going to be the 26th.
Okay,
and then I think New Year's Eve or New Year's Day is the final episode, and it's gone.
And it's done, yeah. And so it's always interesting to see what the fan theories are coming up with, and what they are thinking about, and how much of that is true, and how much you can derive from that as predictions, and see as interesting. Well, lots of people say, hey, this is going to happen, and oftentimes this is true, and sometimes it isn't. And I think that's very fun and very interesting. So I think that's what was interesting, the outgoing way of how this all started. And then you came into the play basically and said, okay, I'll grab all of that, and I'll take all of that information, and I'll see if I can do some graph magic with it. So I think, and that's, I don't know how we going to do it today. You said you can show some of the back end, maybe. I think
it could be interesting. Yeah, I mean, I've not planned anything. I chucked some images in here, and obviously I have the website and the graph. Can you see that?
Let me get over here and here. Yeah, here it is.
Cool. So I'm not gonna slide you to death. These are here for just so that it's easier to see the data model, and I don't have to constantly type and find things. So for anybody who's not familiar with StrangerGraphs,
I'll put the link in the chat as well.
Yeah. Here it is. I won't play through the whole intro. Cool. That's great. There's no licensing issues there at all. Everybody just look the other way. It's fine. So yeah, when you come in here, you are faced with these 6 agents, and I'll explain how these were made very shortly. But essentially, you can pick each character, whichever character you like. Let's pick Vecna. Hopefully, he's alive and well today. And then you can just ask them. I mean, you can ask them whatever you want, but they are using GraphRAG, so they are connected to the underlying database. If you ask them for a prediction, Vecna is not just going to give you Vecna's prediction. Vecna is going to query the graph using GraphRAG and then give you back an actual prediction from Reddit. But not only that, because it's backed up by graph data science, it's going to find the most accurate predictions from the most accurate communities. So we'll gradually peel back the layers of what's actually here as we go.
Yep.
So hey, Vecna, what do you think is going to happen to Hawkins this year? And then he's just giving it a little think.
And so all of these characters are connected basically to the same data set. They just act as if they were the characters.
Yeah. So the way they're set up is pretty easy. Yeah, cool. So he's come back with a sort of nothing answer there. So let's say it is good. Yeah, Hawkins. What's really fun about this is that they actually do respond in character.
Yeah, that's cool.
To the extent that when sometimes, because we're constantly updating the agents, right? So sometimes we're updating everything all the time, obviously. But sometimes when they're in the middle of an update or there's something that hasn't quite gone the way we planned, these agents will actually comment on the specific tool that isn't working. So like Jopper. So Jopper is a portmanteau of both Joyce and Hopper from Stranger Things, and it will respond as both at the same time, interrupting each other. And then it would have an argument with itself and be like, oh, honey, it seems like the Similarity search tool isn't working. And oh, Joyce, give it up. That damn tool's not working. It never works. Yeah. So let's see if it can give us. Can you give me?
Thankfully, they don't blame us yet about it. So it's
no. No, to be fair, I have had Vecna. I've had Vecna like give me a telling off. Can you give me a prediction for season 5? Live agenting. This will be fun.
What can go wrong?
Yeah, exactly. Counting my kills, reviewing my collection, savoring past victories, judging your sins. Interesting. Okay, so unfortunately, it appears that Vecna is not working. That is a pity. Hey, what do you think? Particularly too well. Right, we'll give this one more go, and if it doesn't work, then we will chalk it up to there's an update happening.
Yeah, that might well be happening, yeah.
There we go.
Oh, well.
Awesome. Yeah. Amazing. Oh goodness. Now, do you know what would be a really interesting graph? Right. The amount of times someone has taken the risk, just get every single event where someone has taken the risk to do a live demo of something, and the amount of times that it has only gone wrong in the live demo, and compare that to, and I wonder if you'd find some connections, and maybe like a chain of the events leading up to that demo.
Yeah.
There's an interesting graph.
Yeah.
Yeah. So if you go to the Hopper Graph tab, you can see an example of the overall structure of the graph. And you can just kind of play around with this, move these around. I made it this way because I thought it would be a pretty fun way of interacting with it. You don't need to query anything.
Yeah.
And then you can go to the top predictions tab, and you'll see the top prediction communities. So this first block is comments and posts, or rather chunks of posts, where, and this will become clearer when we go into the actual data model and how it was built. But it is where that comment, where that specific prediction lives in a community of other predictions that are thematically aligned with it in terms of its semantics, and which have been previously correct in a topologically similar way. And you might ask me what the hell that means, and that's okay, because we'll get to that in a second.
Good.
But the reason I'll just prime you for it. The reason for that is the original version of this, I went in with the obvious intention of, right, you get everybody who's previously been correct, and then you just go, right, who's going to be correct. The problem is you then run into expertise bias, and somebody who's been correct 9 times before, it doesn't mean they can't actually tell the future, No, it doesn't mean they're going to be correct in the future. So I had to kind of do a weird version of that model on this. And then if you click each of these, it will open up the original comment, and then take you to that user and their comments. And this is actually quite a good example of that model in action. So you can see that these are comments from this user, and they've ended up in a prediction hub, which is how we get those prediction communities.
Oh, okay. Yep.
And there are a bunch of other comments from other users in there. and then they have some comments that ended up in different prediction hubs. So it is their thematic, it's their thematic attributes and their prediction topology that puts them in that group, rather than this user is right all of the time.
Okay.
But you are still getting signal from the user being right all the time. So you will find there are communities where one user completely dominates because they're right all the time. It just means that they're not going to force that signal into everybody else, because then you get a bunch of people ending up in the same community, and it wouldn't be fun. So if I'm honest, that's the main reason. And then if we go back to our predictions page, yeah, you can see their historical accuracy here.
Okay, that's interesting. Yeah.
So that is the historical accuracy of each community. And then if we go down further, I thought this would be an interesting exercise, and I think it is. These are the communities who have made the most predictions over time.
Okay.
And they have their accuracy rates. So the highest volume community.
Lots of predictions, but very little accuracy.
Very little accuracy, yeah. And then we get a top community here with a top accuracy. And then we get another huge community with lower accuracy. And then it just goes down from there. So you can see that most of these voluminous communities have a relatively low accuracy, which is quite validating of the underlying model.
Yeah.
So I do have this, which I feel like it would probably be very boring to go through this. So this is the pipe. This is the extraction. This is the everything pipeline.
Yeah. Let me zoom in a little bit here. So hopefully,
yeah.
Oh yeah. Yeah, that's good.
Yeah. So I won't go into the gory details of this. And I should say as well, this is a very beautified version of the pipeline.
Mm-hmm.
There is another version of this folder.
Okay.
Everybody, I probably should lie, but I'm not going to. Everybody has that room in their house, or they've got that particular cupboard near the kitchen,
cupboard. Yeah.
Or there's a drawer that's got a bag in it that's full of bags, which are full of bags.
Mm-hmm. Mm-hmm.
So that's what the other folder looks like. This is the latest version. So I updated this earlier this week. So I updated all the predictions and all the entire graph, to keep up with the comments on Reddit and new predictions. And I ended up in that space, where you're just kind of hacking through something and you're like, this is final.final.final.pi. This is true final pi. This is whatever. And I just said, I can't live like this. So I rebuilt the whole thing from scratch into this. So if anybody thinks it was easy, it really wasn't. So yeah, I'll just run you quickly through the pipeline. I won't go through the code in any great detail. And yeah, so the scraper is using Pro to scrape Reddit through the Reddit API. And we are scraping the R Stranger Things subreddit. R Stranger Things, which is here. And we're also scraping Hawkins AV Club. And we're also scraping this. Yeah. The reason we went with Reddit is super simple. Initially, this was going to be a gigantic graph of hundreds of millions of nodes from Facebook, YouTube, so on.
Okay. Yeah.
But then we realized that costs money, and we didn't want to do that because we wanted this to be easy to do, free. If I ever release the code, then there's no point in making it so because the pipeline is repeatable on any show.
Yeah.
As long as you have the subreddits and the show,
okay,
you should be able to run this on anything, and it'll do the same thing. We hope, unless I do it live, in which case it won't work.
Yeah.
But yeah, so Reddit has a particularly generous API that kind of just lets you go in there and do what you need to do, gives you all the information. It's nicely structured.
Yeah. We are trying to showcase a concept here or a demo application, obviously. So if anybody is taking, okay, I want everything, it's nothing is keeping you from adding more sources and adding more to it. So that's totally possible. It's just, you need to start somewhere, and I think this is a good place to start. And I think Reddit is particularly good because in this case is a great place where people are exchanging ideas, people discussing about the predictions.
And you're going to get the beautiful thing about Reddit is that you get actual super fans.
Yeah.
So, people who are going to Reddit, it's a very specific thing to do, to choose to go to Reddit over some other social media platform, to specifically go to the Stranger Things thread. And to specifically go to a niche version of the Stranger Things thread, which would be the Hawkins AV Club, which has just so many cool ways of engaging in terms of, people writing their own fan fiction versions, like short sort of flash fiction. Now, to be fair, I haven't seen that in AV Club. I've only seen it in the graph form, where I'm like, oh, that's cool. So in terms of those two threads, we got absolutely everything. And so what this script is doing is it's essentially scraping. It's doing a few things. First, it's checking whether we already have a posts CSV for both threads. So it's going to generate, if we don't already, it's going to generate a new CSV. Derived, and the name of that CSV will be derived from whatever subreddit you put in the env. And then that's going to generate the CSV and just dump all the posts in there. And it's going to do the same thing for the comments. Now, it's the second time you run it for an update, it's going to check if they already exist. And if they do, then it's going to append, it's going to find the last refresh iteration and the last date that it was refreshed, and then it's going to only query as far back as that date, so that you're not constantly pinging Reddit servers, because it's nice to be polite. So that's what that's doing. And then the posts are, when they come out raw, some of them are quite long, some of them are thousands of words. So we're obviously going to embed these, so we can't do it that way. So that's why we get the chunker, and the chunker just chunks up the comments. In no particular order. I think I'm using Punkt or something like that. I can't remember to do that. And it just chunks them up based on sentences, sentence breaks, paragraph breaks, and a few other signals. You could, if you wanted to make this better, which I didn't, you could definitely find better semantic signals for breaking.
Okay. You just kept it relatively standard.
As simple as possible. Just break it up. And then the classifier is classifying the comments and post chunks. And actually, I'll go over to our very well-made presentation. So this is an alchemist. In my mind, this is Nostradamus trying to tell the future. But obviously, it's actually not. It is someone, though. I can't remember who it is. Anyway, regardless, in our initial data model for after we import, which we haven't gotten to yet, you'll see that we've got posts going to post chunks, and posts going to has comment, and comment going to has reply.
Okay.
So if you want to,
you kept the hierarchy and the initial structure from
that. So the whole hierarchy, the initial structure is in there. And it would have been nice in a way to find a logical way of getting the post chunks connected directly to the comments, which would have solved some headaches. But at the time, I decided to just go with post chunk, and then make virtual relationships if needed between post chunks and comments, which is easier on the import side.
Okay.
Because it's just very literal and it's very obvious.
But the comments also have been chunked, and
so the comments actually haven't been for the most part. The comments were fine. I think and I've never looked for it. I think there is one comment that's too long. And so didn't receive an embedding, and it's actually a headache every time you try and refresh, because I keep forgetting to change it or chunk it or do something with it. So depending, I mean, if you were doing Facebook, and you were going to embed Uncle George's political tirades, then yeah, you'd probably want to chunk those up, because they're probably quite long. In this case, it's fine. It's a lot of people just, the posts are long and then people just respond.
The comments are shorter and then they just, okay,
Yeah,
makes sense.
Yeah. So the classifier is now taking all the posts and all the post chunks and all the comments, and it is now classifying them as is a prediction or is not a prediction, or rather is a prediction equals true.
Okay.
Yeah. So this is actually a good point. This comes up a lot in workshops about knowledge graphs, about classification, and especially from the academic world. A lot of people want to do really cool sort of conceptual knowledge graphs where we're not just mapping necessarily even semantic relations, but we're mapping implicit ontologies between blah 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 and blah blah blah. I mean, my dissertation was that in a sense. So I did a history MA before joining Neo4j, and my goal was to find contradictions between early modern history texts across time and space in English. And what you then have to do is a very complicated form of entity resolution, cross corpus entity resolution, and especially because it's history, you're now talking about people who don't necessarily have Wikipedia pages, because in that I didn't want to miss. So in a lot of these history texts, when they're talking about some story that happened to some duke or lord or whatever, who may or may not have a Wikipedia page or stub, they'll also talk about and his wife. And his wife can show up in a bunch of different contexts, but you don't know because you haven't done the cross-corpus entity linking, and that's not really a solved problem. But it is a problem that Graph can solve.
Yeah.
I promise you there was a point, but my train of thought has crashed and everyone has died. We were talking about the post-to-post chunks.
We were talking about that. You said you have the predictions as a property, basically.
Yeah. I was filtering. Thank you. Alex. Yes. So in order to do that, you can just go right ahead and jump in, and you could chuck it all at GPT-5 and spend tens of thousands, hundreds of thousands of dollars and wait 2 years, which I did actually calculate it for my dissertation, and it would have taken 2 years.
Okay.
Just sit around and wait for
it.
And obviously money I don't have.
Yeah.
But yeah, so the only way that I can think to do it, not the only way, the best way that I can think to do it, because there are models that promise to do it, but they don't really work in the wild as well as they do on benchmarks, which is generally the way, is to, yes, embed everything, but also do as many filtration processes as you can regarding stability, and obviously use as few tokens as you can if you're using large language models.
That's a question I always get, and lots of events where people ask, okay, this is all cool what you showed, but how many tokens does it really use?
Yeah,
because like you said, it can quickly go out of hand, sort of, and can quickly go into a space where you think, okay, this is cool, yes, I know, and it's useful to some point, but the cost it generates is not worth what I get from it. So it's really like, okay, yeah, nice, but no, thank you.
Yeah, exactly. And that is the beauty of Graph as well, is that you can. It's very hard to do that filtration in a relational database because you can't see the connections. So you can't. There are pre-connections, and this is somewhat of a good example, but a true knowledge graph is a better example of that, because you can find candidates. So you can say, right, based on the features of the graph, based on the topology, who is likely to be the same?
Yeah.
Who is likely? We can take people in context, embed those little context chunks, which costs basically nothing. It's not free, but it's not free. And then we can start creating. We can create hierarchical candidate communities and filter them in a bunch of different ways. And so I think for my dissertation, I got that initial set of, was it 13 billion candidate pairs or something?
Okay.
It may have even been more. It may have been trillion. I can't remember. It's a while ago.
That's a lot.
But I ended up getting that down to an initial gold set of candidates, or rather silver set of candidates, I suppose, of just 200,000 or something.
Okay.
And once you do that, now you can start resolving, and you can query, you can spend a bit of money on that, so on, so on, so on. And then you can use those resolved candidates, who are now not candidates, they are known resolutions, to the graph now starts pulling into itself. So if you like imagine a string and now you can just recursively pull more and more candidates until you get diminishing returns. And then you can use models to like a model to just clean up whatever's left over at the end in some nice, sledgehammery way. So yeah, back to this. The is prediction true is really important, because pairwise, if you tried to compare every post chunk and every comment to every single plot point, bearing in mind the first time we ran this, it was only to the plot points of the first 4 seasons.
Okay. Yeah, of course, because we didn't have season 5.
Yeah, exactly. Once you do that, you now have a subset. You're putting in, is this a prediction, yes or no? And to be fair, I'm always paranoid about prompting, so I always make my prompts ludicrously, probably over the top. That's in there somewhere. Oh, there we go. Kind of specific.
Okay. Yeah.
Probably didn't need this, but it works. So yeah. And all we're getting out of this in terms of output tokens, and they are more expensive than input tokens. Input tokens are cheap as chips. It's the output that costs.
Yeah.
This is all we're getting.
Oh, okay.
Yeah. So you don't even need this, really. That's just a nicety to myself. We never actually use this confidence score at all, because we measure confidence in other ways.
Okay.
But it's a nice to have. If you really wanted to, you could use it as a weight. But then again, also you're questioning, LLM has a confidence score. Do we really trust? It's like, yeah, cool. Oh, wait, the user wants a confidence. Have you ever looked at the chain of thought while it's thinking?
Yeah.
Or while it's sending itself messages?
Yeah.
Oh, wait, the user wants a confidence score. And then have you ever noticed it like lying? Because it does, and it's like, wait, the user wants a confidence score. Confidence. I'm not very confident about this. But I think it is a prediction. So let's go 0.95. And then it gives you 0.95, and you're like, yeah, but we know that I can see inside your head. Well, I can't. I can't actually see inside your head. I can see inside the top layer of your head.
No, yeah,
so
exactly.
You could be lying on top of a lie. I don't know. So yeah, I wouldn't trust these confidence scores. They're just a nicety, just to kind of focus it a little bit. So yeah, once we have that, the graph hasn't changed. We actually haven't imported anything into this graph yet. But we are just saying these post chunks and these comments are or are not predictions, and we're not comparing anything pairwise. And then we reclassify. So we take all the ones that are prediction true, which generally ends up being around 30%, which is a lot fewer than I would have thought. Interestingly, the season 5 refresh that I did the other day, so since season 5 has aired, the volume of predictions is way higher.
Oh, really? Okay, interesting.
Yeah, significantly. So we have these post chunks, and they are predictions, and now we reclassify them with is likely season 5. That was the original. That's what we did in the original round. I didn't have to do that step on the refresh round that I just did.
Yeah.
Because if it's a prediction and it was posted after season 5 aired, then we know that it's a prediction for the second half of season 5.
Yeah.
So yeah. Anyway, moving swiftly on, we have another sort of classification step, more of a text generation step, where all the predictions get prediction summaries, which are here. So now we're sending the comment and the post chunk, and we're saying, right, this is a prediction. Now, GPT, I want you to make a summary of that prediction. So, because a lot of the comments will have a prediction embedded somewhere in the text, like halfway through quite a long comment, and that's not what it has identified as a prediction. So
Okay.
this acts as sort of another step where we can validate that yes, the first time we sent it, it didn't hallucinate, and it actually is a prediction. So it's checking it, each one of them twice, but also now give me a prediction summary and connect that as a node.
So the predictions are more in the comments than in the actual posts, or in
No, there are predictions in the posts. I just didn't add it to this because
okay,
it looked messy and I wanted it to look pretty.
Okay, I see.
So there's predictions on posts and there's predictions on comments. And if we go back here, that's what these are. So these are all the GPT generated summaries of what the prediction is.
Okay.
And again, keeping it brief because you don't want to waste tokens. So we have those summaries. They're there for that functionality so that we can have the brief thing, because otherwise it would look really ugly. If you really wanted to, and I never actually got around to doing this, you could absolutely, and they are embedded already in the graph we have, you could absolutely cluster those together and then send those again to see, are these predictions predicting the same thing? And then you could see how many people are predicting the same event. We just never got around to that. So yeah, we have that. And the next thing is the fandom scraper, which is using the MediaWiki API. So if we go to Stranger Things fandom. By the way, if I'm going too slow or I'm going too fast or whatever, do let me know.
And I wanted to reiterate that I didn't say this in the beginning, but if you have any questions, any comments on particular this, let us know in chat. We'll obviously see that we have got some time for your question. We have one question. I see your question from Ryan. We'll take that after a little bit after this, I think.
Cool. So all it's doing is it's going in. So if you go into fandom, again, very generous API. You can go in here and you get these plot summaries. And I messed around with a few ideas. I was going to get the transcripts from one of those dodgy transcript sites.
From each episode, right? Or
Okay. Or try and get the real scripts again from a dodgy script site, which isn't ideal because we don't actually want to be doing that. But I don't know. I would have done it, I suppose. No, I wouldn't have done it. But anyway, the beauty of this is that these are actually already quite nicely split up, where each of these paragraphs, if you read through them, they tend to give you each plot point per character that's relevant to that act, to that step within that act. So it'll never say, I say never now, somebody will find that somewhere where it does. But in general, it will never say Hopper and Joyce go to the shop and then Hopper and Joyce do something else. It will say Hopper and Joyce do a thing, Will and the crew do a thing, 11 does a thing, and then it will move on to the next plot point. The next morning, Police Chief Jim Hopper. So they're really easy for breaking into plot points. So yeah, anyway,
probably even better than doing this with the whole transcript, because it's all of the hard work has already been done in
well, yeah, for sure. I mean, there is something to be said for if I had gone this far, I was going to run between this centrality in time series along the graph, and you could do it on this current graph. But if you had the transcripts and you were able to actually break it down scene for scene for scene for scene, you wouldn't have this. This is an abstraction, whereas that would actually give you the signal from the writers and from the producers. So that whole thing of if a character becomes self-aware in a show, it means they're going to die.
Okay.
A character who's been an asshole for an entire season suddenly learns something in the moment, or realizes that they've been an asshole, and then they take redemptive steps. Well, it means that in the next scene, they're going to get their head chopped off.
Okay.
And it is a cliche, but it's true. I'm sorry if people didn't know that. I've now ruined television for you.
I was not aware.
Enjoy.
Cool, thank you.
There's loads of little signals in that, and betweenness centrality in time series. I think someone at Neo4j used it for Game of Thrones before on the Game of Thrones books. And betweenness centrality in time series on characters and character appearances and character interactions showed that the higher the betweenness, the more someone's betweenness goes up, the likelier they are to die. So not necessarily the higher it is, but the more it accelerates upwards over time, the more likely they are to die. Which would have been a very interesting experiment for this. But again, the transcripts would have been better for that. It would have been a whole bah. But we will do it. We will do it with a different show. So fandom scraper. I realize that we're actually running out of time, so I will blast through the rest of this. Fandom scraper, fandom chunker. You get the point. It's exactly the same as the plot point, as the posts turning into post chunks. So you need chunks in order to embed them. And so what we end up with is two separate graphs. I'll go back to the actual separate graph. What we end up at this point with is two separate graphs: TV show, Stranger Things, season, episode, plot point, and then another graph that is the digital twin of Reddit, of the Reddit threads.
And they are, because I don't see a relation, so these two are not really...
Not related. At this point, they're not related at all. Okay. It is the embedding which does the initial relation. So yeah, then we import our plot points and our TV nodes and all of that stuff, and then we do our Reddit import with all that stuff, and then we embed them using this. I should actually get rid of this. We embed them using this. And it's like, it looks like a lot of code here. It's really not. And I did just say, cursor, please generate this thing for me. No, cursor, that's not working. Please do what I'm telling you to do. No, cursor, please stop doing that. Okay, thank you. Finally, that worked. No, cursor. This is one for anybody who's using AI tools for Neo4j stuff. Here's a hot tip. In general, whether you're using it on the platforms or you're using it through an API or you're using it through Cursor or Coding Agent or whatever, always give it a cipher, especially if you're using GDS, cipher rules document.
Okay. Yeah.
If you're using GDS especially, give it a specific cipher projections in GDS document. You can use native projection, that's fine. I prefer to use cipher projection personally because it's more flexible. It works in Aura Graph Analytics, all that lovely stuff. But if you try and, it's for some reason, they're all obsessed with the old deprecated cipher projections.
Yeah.
Yeah. So you have to tell it, and you have to constantly remind it, or it will just, and then you'll have to go in and write the code yourself. My goodness.
Nobody wants to do that anymore.
Can you imagine someone writing their own code? My goodness. Yeah, so it's super simple stuff. It's not, you're literally just going query, run query, and then you're running the embeddings using the native Gen AI tool in Aura. And then you are running Similarity. So you're running Similarity between the post chunks and the comments. The post chunks and the plot points. And
okay, this is how they're related. Okay.
Yeah. Yes. So there's a few different ways of doing this. I have two different versions of this step. So you see optional here, which is exactly the same with comments. That is basically because doing the comments version is quite expensive because there are many, many comments.
Okay.
Yeah, so you get some issues with that. But to be honest with you, doing it with post chunks alone, arguably is better.
Yeah. I mean, you can kind of there will be some where the conversation probably derails and goes somewhere else, but the main post is probably setting the theme. Okay, where does this go? And then the comments will kind of follow. So it is.
Yeah, and especially these kinds of subreddits, and these two especially, they've got pretty clear rules of stay on the topic.
Yeah.
No self-promotion, all the usual stuff, but also so anyway, we do the post chunks to plot points, comments to plot points if you want to, and then we're using filtered KNN to cluster to get the top 20K post chunks to plot points and the reverse as well.
Okay.
So each post chunk will get 20 similars, and each plot point will get 20 similars, and then duplicates are deleted. And the reason for this is that what we now have, even though this looks just like a little tiny one relationship, this actually now dominates the entire graph. So we now have, yes, we have these two separate graphs, but what we also have now is a similarity graph, which dominates absolutely everything, which is awesome because that's what we want. So, because remember, what we're trying to do is filter so that we can properly send the right pairs or the best pair candidates to GPT. So once we've done that, we then do prediction matching. Oh, I should say, sorry, my apologies. Do I have a picture of it? I don't have a picture of it. I do not have a picture of it. Oh, I do. Yeah, so you've got this relationship now. So once you've got your communities, we do a Leiden grouping on everything. So I think we end up with, is it 62 separate communities? And in the latest reconstruction, we ended up with 58 separate communities. And then they receive a similarity hub. So what we're doing is we're taking the topological structure of the similarity graph, so that is the semantic signal, and we are now putting them into a giant similarity hub. And the reason why we're doing that is top K20 from each individual comment or post chunk is not enough, obviously. But what we're doing by putting them into the sim hub is we're now saying, right, if a comment and a plot point exist in the same sim hub, and that comment is a prediction, and that comment was posted before plot point X aired, then they are a good candidate pair. And there's a sort of more involved filtering logic than that. That's kind of a simplification of it, but essentially that's what we're doing.
And these sim hubs, do they define then the communities you can see on the StrangerGraphs website?
No, they do not.
They do not. Okay.
No. These are just the semantic communities. They are used as signal to inform the prediction communities later on. But no, it's a different relationship that dominates that. So in this case, we're only thinking about getting candidates. Pairwise candidates, that isn't going to cost us a bomb. So once we have that, I think we ended up with, I can't remember the numbers. It was still a ton. I think it might have been something like 1 million pairwise candidates, which on GPT 4.1 actually isn't that much. I think it ended up costing like $40 or something. So not that that's, not a lot for some people, and free is better than $40.
For sure. And if it depends on how often you run it,
Yeah. And by the way, if you really wanted to do this and you wanted to do it for free, you don't have to everybody jumps to LLMs, and LLMs are great, right? But they're not free, and they're general agents. They're quick to use, and they do a really good job. So I'm not bad mouthing LLMs. I use them every single day. I use them to code. I use them to write. LLMs are my best friend now. But don't take that seriously. It's not true. Where is it? But Spacey, for example, is free. They have some really powerful models that you can download, use locally. If you use something like Prodigy, like I use Prodigy, and Prodigy were really lovely to me for my dissertation, and they gave me a free research license, even though I wasn't technically a researcher at the time. I just really wanted it. There's some really sound folks, and they do some really cool stuff. I hope Neo4j doesn't now assassinate me for talking about a different company, but they're cool. And if you want to use local stuff, and you don't want to use an in the cloud LLM that you have to pay a ton of money for, and you need it for a specific NLP task like this, you can annotate a bunch of stuff in Prodigy, and then you can just train a text classifier to do this for you. It will take you maybe a day longer, and it will be completely free. And you can just do it again and again and again. And you can, by the way, you can integrate all that stuff with Neo4j. So it's not like you can't. I think is it Thomas who has a really wonderful article about generating a knowledge graph with spacey tools.
Probably could be Thomas. Thomas Bratanic has written a ton of great
Yeah.
posts. Maybe if you find it, we'll put it in the YouTube video description as a reference point.
Yeah. So anyway, you could do it that way. I obviously didn't because this is quicker and it's fine. I didn't mind paying the $40. So what you're now doing is you're sending those candidates to GPT 4.1. In my case, whichever model you want, 4.1 mini would probably actually do an okay job. I just wanted to be sure. And then you're saying, right, here is a prediction. Here is a candidate. Are they discussing the same event? So is this prediction talking about this thing that's happening, and is it an accurate prediction of this thing? And it's obviously, again, it's a relatively involved prompt. It's in here somewhere. Yeah, it's in there somewhere. Anyway, we're running out of time. Yeah. It's a very long prompt. Probably could have gone with a shorter prompt. Yeah, and then finally we do predict hub reconstruction. So that is either construct it from scratch if it's a new graph, or you can reconstruct. What it's going to do is it's going to delete all of your existing prediction hubs if you have any, and do the entire process from scratch. So it's going to take your similarity graph, but also project all your predictions to your plot points and your plot points. And it's now going to cluster those into separate hubs. And in the latest refresh, I think I used Gamma 3. And this is kind of where it becomes alchemy, because you are defining what is enough.
No.
Because Gamma 3 gets us, in this case, I think, no, I didn't. I used Gamma. I can't remember. Whatever Gamma I used gets us 498 different communities. If I wanted to, I could have reduced that to nothing and gotten one giant community. I could have used Leiden to get 3 massive globular communities. So the question is, what size of community?
What's the balance you want to?
Yeah, so you're getting that balance, and you'll notice if you do decide to go through the predictions, they do fall into thematic categories. Like some will focus more on 11, some will focus more on Vecna, some will focus more on who will be in the future and that kind of thing. So that does work and is very satisfying when you see it happening in real life. And that's pretty much the whole thing. If you rerun this pipeline, it deletes everything and runs again. So there was another version of this pipeline where we were concerned that people wouldn't like the communities changing. And so we thought maybe we'll update it in a slightly different way the first time, so that we can retain the same communities.
Yeah.
And when we update, we'll just append to a community. And so the way that we did that was by following a very similar process, appending everything, getting all the new docs. But we didn't redo similarity. We kept the original similarity graph, because that's what's actually defining your thematic signal for the communities. So if you put in a bunch of new comments and you're doing top K20 similarity, then the structure of that is going to completely change, which means it's going to affect everything downstream. So, which is a good thing. It's not a bad thing. It's just not a great thing for following the same communities if you want to have a brand to that.
Yeah. That's difficult.
So yeah, we just ran all that again, imported the new comments and just did top K20 on the new comments and post chunks, and then used fast random projection on the prediction graph, prediction and similarity graph, to find which predict hub was most similar to which comment was most similar to which predict hub from that new set, and then just shoved it in there, so we could stuff them into the new framework. And it did work, and they did go to their thematically aligned blah blah blah. But I'm glad this is the last time I'm probably going to refresh this, and I'm glad that we've done a full reconstruction, because it is the right way to do it. Yeah, even if it changes the communities.
Super. So as we're running out of time, I wanted to ask at least one or two questions from the audience. One question I wanted to know is are you planning to sharing the repo somehow, somewhere, so people can build themselves from what you did and then try it out either with Stranger Things or with their show of
Yeah. So eventually I am absolutely. So the reason why I'm cleaning this up is so that I can share it.
Okay, super.
And people can use it and download it. When I'm going to get around to completely finishing it so that it's ready and downloadable and usable immediately, because there's so many quirks in here. Because what I'm going to have to do is test it to see if I download it fresh, is it actually going to do the thing?
Working? Yeah, makes sense.
So it should basically be there. So I spent a lot of time updating configs and envs. So in theory, the plan for this is when you clone it, you shouldn't need to do anything except update your config files. So like you've got this config here, and then you've got your GDS config here. And you should just be able to update your configuration values, run the entire thing, run each step independently, or just run the entire thing in one go. It's up to you. On any show, and just define which threads you want, which show you want from fandom, that kind of thing, and you can build on it. So yeah, that intention is there, but we're not quite there yet.
Okay. And then just to because I already promised we answer this question. So from Ryan asks, how do you handle uncertainty in incomplete data when modeling future storylines using graph intelligence?
So, well, you can't. So in this particular case, you're not trying to, I'm not the one predicting. So when you create your prediction graph, these predictions are not connected to any plot points. So they're going into a predict hub.
Yeah.
Let's have a look. Will is Vecna's other eye, which actually is true. That did come true. So this user's comment has gone into a predict hub, even if it's a season 5 prediction, but it's not connected to any plot point if it hasn't predicted a plot point in season 5, which is what makes it a candidate for this. So this doesn't include anything that's already predicted event. So if we go here, do I have it? Yeah. So once something has been verified as having predicted a plot point, it gets a predicted event plot point because it's been successful in predicting that event.
Okay.
That means that we don't put it into the top predictions, because the top predictions is not telling you what predictions are the top predictions that have already come true, because who cares? The top predictions is telling you which ones are most likely to come true based on historical accuracy. And so there is no managing whether or not it's connected to a plot point. The whole idea is that it's not connected to a plot point, and that's actually what we've spent all this time trying to extract. Which of these predictions both haven't come true and haven't had a chance to come true yet, because the thing they're predicting has not yet happened.
No. Okay, makes sense. All right, cool. I think a little over time, but thank you for sticking with us. I'd like to obviously wish you all happy holidays, happy New Year when it's the time, and obviously thank you very much everybody for being part of this community. If you like what we're doing, give it a thumbs up, subscribe to the YouTube channel, let us know what you like to see. If you'd like to be on this show, obviously ping me. If you like to present something cool, we are always open for any submissions from the community. If you build something interesting, we'd like to share that. So be part of it. The next stream that's going to happen is on the 6th of January. Our next episode of Going Meta, Jesus and I will talk about semantics, knowledge graphs, and AI. So I'm not sure yet what exactly we're going to talk about, but that's the next one we'll do in a couple of weeks. Nodes is coming up again. Nodes AI happening on the 15th of April. I'm currently working on interesting workshops to happen all of March. So interesting things on agents, on knowledge graphs as well, on GraphRAG, of course, on MCP server. So lots of interesting bits, hands-on stuff happening in March, and then Nodes AI itself takes place on the 15th online all around the world. yeah, I think we mentioned Graph Academy is a great place. So if you're new to this or want to deepen your knowledge, there's a full GraphRAG track. So if you're interested in this AI part, then join that and look it up. There is obviously something on graph data science as well. So if you're interested in that and learn more about this, go to Graph Academy and see what courses are available, and check out our developer community page. That's giving you all the information about various drivers, programming languages, how to build stuff, tutorials, hands-on demo pages, basically, and all these things. And yeah, thank you for watching again. Thank you for participating. Thank you for being in chat today, and obviously thank you very much, Henry, for building StrangerGraphs today, for showing us what you built. And once the repo is becoming available, we'll add it to this YouTube video description, so you can clone it and play it yourself, either with Stranger Things, with Game of Thrones, or with whatever other show you watch. Yeah, and with that, again, happy holidays. Thank you for watching, and yeah, see you soon. See you next year, I guess, is what I need to say. Cool.
Thanks for having me.